Hello, math lovers. Today's question comes from section 2.1, which is about inputs and outputs of functions. It's problem number 35, and it states the following. Let s of t equal 11t squared plus t plus 100 be the position in miles of a car driving on a straight road at time t in hours. The car's velocity at any time t is given by v of t equals 22t plus 1. So let's look at what we can surmise from this statement. So this first function is for position, and the input is time, t. The position is translated in miles. And the second formula, this one here, is velocity, which is the time and miles together, which is miles per hour in this case. So our first question says, use function notation to express the car's position after 2 hours. Where is the car then? So 2 hours, we know that t is time, and so it has to be an input. So s of 2 is our function notation, 2 being the input. So we plug the 2 into this formula, 11 times 2 squared plus 2 plus 100, and then what we get is 11 times 2 squared, which is 4, plus 102, which is 2 plus 100. And to go further, 11 times 4 is 44, plus 102, and we get 146 miles. That is the car's position after 2 hours of driving. Now, the second question is, use function notation to express the question, when is the car going 65 miles per hour? Now, function notation, like the first question, is asking for something in this configuration, s of 2. In this case, 65 miles per hour is the output. In this formula, t is the input, t is time in hours. So v of t equals 65 miles per hour, the output, which equals this formula, 65, or function, 65 equals 22t plus 1. So to figure out when the car is going 65 miles an hour, we solve for t. 65 is equal to 22t plus 1. We subtract 1 from both sides, and we get 64 is equal to 22t. To isolate the t, we divide both sides by 22, and what we get is 64 seconds equals t. Well, we can divide both the numerator and denominator by 2, and what we get is 32/11 hours. After a little less than 3 hours, the car is going 65 miles per hour. Now our final question is, where is the car when it is going 67 miles per hour? Well, what we have here is a velocity, which we know is an output from this question here, because they're very similar. And we want to know where, which is a position. Well, we can't get there directly. First, we need to find out what t is. So we're going to use what we have, which is this output, to figure out t. 67 is equal to 22t plus 1. We'll subtract 1 from both sides. We get 66 is equal to 22t. Again, we divide both sides by 22 to isolate t, and what we get is 66 over 22, which simplifies to 3. So 3 hours is our t value. So after 3 hours, the car is going 67 miles per hour, but where is it? Well, this first one, we have t is 3. We're going to plug s of 3 to find our position into the formula. So we have 11 times 3 squared plus 3 plus 100. That equals 11 times 9, which is 3 squared, plus 103, which is 3 plus 100. To take it further, 11 times 9 is 99, plus 103 equals 202. So now we know when the car is going 67 miles per hour, it will be at 202 miles. Hope that made sense. Thank you for watching.